The earthquakes that shook Turkey and Syria this month, killing thousands, have fractured the country's transport networks. The 7.8 magnitude earthquake destroyed roads and collapsed buildings onto roads, rendering some routes impassable and effectively rewriting the map for some cities overnight. That's made it harder for rescue workers to get aid in and the injured out. But now, aid workers have a number of technological tools at their disposal to find new paths through the rubble. Here's how mapping technology could help the rescue efforts in Turkey and Syria. Firstly, there's drones. It might seem obvious, but drones can instantly give those on the ground a real-time bird's-eye view of a disaster site, helping aid workers identify the safest or easiest route through obstacles and informing them of which paths are completely impassable. The visuals can also be used to help rescuers identify areas that might not have been searched, and even potentially spot signs of life among the wreckage. What's more, they can be deployed to try and assess the structural integrity of a building, giving rescuers an indication of whether it might be safe to proceed. Spain has said it is sending drones to Turkey as part of its aid package. But to get a bigger picture of how road infrastructure might have been damaged by a quake, you need to go higher, much higher. Enter Copernicus. The Copernicus programme is the European Union's eyes on planet Earth, and is funded by the Union to monitor things like floods, lava flows, wildfires, and earthquakes. In addition to their own sensors, the group sources high-resolution satellite images from companies like Airbus, Maxar, and Planet Labs, and combines them with data and analysis to create a new map of a region in under 2 days. See, mere hours after the Turkey-Syria earthquake struck, the Red Cross activated the European Union's emergency mapping service, and Copernicus began analysing satellite images of affected areas. Through a combination of algorithms and human analysis, the group has been able to identify roads that have been destroyed and buildings that have collapsed. That open source information is then published for all to see and updated regularly, giving rescue workers a fresh map of their surroundings. But what if you could predict which areas of a city were most likely to be cut off in the event of an earthquake, so you could reinforce those areas to try and make sure they remained connected? Well, that modelling tool is exactly what engineering researchers Dr. Cihan Björn and Professor Dina Dayala have tried to develop. The pair worked with Istanbul's metropolitan municipality to develop a model for evaluating which areas are most at risk of being cut off in the event of an earthquake. To do this, they took data on things like building density, seismic strength, vehicle throughput, and road layout to create a heat map, which not only shows which roads and buildings might be damaged in a quake, but also which roads might become blocked if a building collapsed, and crucially, which areas were most at risk from being entirely cut off in the event of an earthquake. The research could also be used to show where investment could increase resilience against earthquakes. Essentially, whether it would be a better investment to strengthen a building or strengthen the road, or add more connectivity to an area. Now, the study was only published last year, and the researchers tell me it takes a lot of granular data in order for the model to work. But in the future, it could potentially be a tool that cities use to try and keep a path clear in the event of an earthquake.